Alright, so we're going to start section 7.6. We just got done talking about the tangent, and as I talked about, I believe in the 7.5 video, the next thing we're going to talk about is the other two trigonometric functions, trigonometric ratios for acute triangles, and that is the sine and cosine. Okay, so the sine and cosine. Alright, so that's what we're going to talk about now. Very, very similar to tangent. The only thing that changes is the different parts of the right triangle that we use. In tangent, we took the opposite over the adjacent legs. Sine and cosine are different. We're going to use the hypotenuse for sine and cosine. That's why they're kind of lumped together here. So let's move right into what exactly is the sine and what exactly is the cosine ratio. So here I have a triangle ABC, and we want to make sure that we have a right triangle. Okay, so this is a right triangle ABC, and I want to first talk about the sine. Okay, so the sine, how about of angle A? The sine of angle A. The definition of sine, it's a ratio, remember. It's a ratio, so it's going to kind of look like a fraction, and it's the length of the leg opposite angle A. So the leg opposite angle A divided by the length of the hypotenuse. So the length of the hypotenuse. Okay, so when we talk about the leg opposite A, remember, if we look at angle A, the leg opposite is going to be this leg right here, BC. Okay, the leg opposite of A is BC. So let's write that in. So this is going to be BC divided by the hypotenuse. Well, the hypotenuse is just this leg. Is the side opposite of C. So that's going to be AB. So BC over AB. Okay, and that's the sine function. The cosine, ratio. I'm not sure why I keep saying function, but the cosine ratio. The cosine of A, well, that's the length of the leg adjacent. Remember, adjacent means next to, leg adjacent angle A divided by the length of the hypotenuse again. Okay, so that's my ratio. So once again, I look over here and I say, all right, here's angle A, right here. The leg adjacent to it is AC. Okay, so once again, I look at angle A, and I've only got two sides of the angle. I've got AB, that's the hypotenuse, so that could not be the leg adjacent. AC is the only other leg that's touching angle A, so AC must be the leg adjacent. Okay, so this is going to equal, let's try a different color here. This is going to equal AC divided by the hypotenuse. Once again, the hypotenuse is AB, so divided by AB, or AC over AB. So that's the sine, opposite over hypotenuse, and the cosine, adjacent over the hypotenuse. Okay, in this first example, I just want to find the sine of S and the sine of R. They're going to be the most straightforward application of the sine ratio. Okay, so the sine of S, remember, is the opposite of S. So let's kind of highlight what we're working with here. So I'm talking about angle S right here. Okay, so I want the opposite side of S, so the opposite leg of S. Well, that's going to be, and I hope that you guys can see this on your sheet a little bit better. This is 63 right here. But that's going to be RT, right? RT is opposite of angle S, the opposite side leg of angle S. So that's going to be RT over the hypotenuse. Well, the hypotenuse is 65, right? So 65 is my hypotenuse. So that's also RS, right? So RT over RS. RT is 63 divided by the hypotenuse, which is 65. Okay, and so once you've got that, you can find the decimal for that if you'd like, but I'm okay with just 63 over 65. Now let's talk about the sine of r. Okay, so that's going to be a little bit different. I'm taking the side opposite of r. So I check out angle r right here. Side opposite is ST. Okay, so sine of r is going to be ST divided by that thing on the hypotenuse, right, which is once again RS. Okay, plug in my values. ST is 16 divided by the hypotenuse, which is 65. Okay, 16 over 65 is the sine of r. Once again, decimals are okay. Leave it as fractions. That's fine also. Okay, so now let's talk about some kind of straightforward examples of cosine. Okay, so I'll go through cosine a little bit quicker than I did sine. Cosine is the adjacent over the hypotenuse. So if I want the cosine of u, talking about the cosine of u, I want the leg adjacent to it. Well, that's going to be, if I'm looking at u, the leg right next to it, uv, divided by the hypotenuse. The hypotenuse is 30, or WU, or well, why don't we say UW? Okay, so UV is 18 divided by the hypotenuse, which is 30, and you can simplify the fraction if you want. I think you can take, what, a 3, so 6 over 10. This is going to reduce down to 3/5, I believe. And that would be fine. You can change that to a decimal also. Either one is okay. Let's talk about cosine of W now. Right, so we're looking at W. I want the side adjacent W, 24. Okay, not the hypotenuse, right? The hypotenuse is the only other thing that it could be that's adjacent to W. It's not that, because the hypotenuse is, well, the hypotenuse. We need the leg adjacent, which is WV, or 24. Okay, so WV, and over the hypotenuse, which once again is UW, that's going to give me 24 divided by 30. And once again, you can simplify this fraction to, I believe, 4 over 5, and then you can leave it as 4/5. That's fine. So once again, straightforward application of the cosine function. Okay, so in this picture and in the next example too, we want to find the hypotenuse. So let's quick identify what the hypotenuse is. I've labeled it as h right here. So h is my hypotenuse. This angle is 48 here, angle R. This side RT is 9, TS is 12, and I want to find h. How am I going to do that? Well, I'm probably going to use sine or cosine. How do I know which one to use? Well, that's based off of my given angle. So if I'm given 48, and then I'm given the side adjacent, and I'm looking for the hypotenuse, I could use the cosine. I'm also given the side opposite of 48, which is 12, and I'm looking for the hypotenuse. So either sine or cosine would work perfectly. It's really up to me. I'm just going to use cosine, just kind of pick randomly here, and we'll go with the cosine. So the cosine of 48 equals the adjacent over the hypotenuse. So the adjacent right here, remember, is 9 divided by the hypotenuse, which is h, what I'm trying to find. Okay? To solve this for h, I need to, so really the geometry is done. The rest is just algebra. And remember, like tangent, cosine is just a number. Okay? So we can multiply both sides by h. Okay, and on the left, I get h times the cosine of 48, just a number, equals, these h's cancel out, equals 9. Okay, and then cosine 48, I want to get h by itself, so let's divide by cosine of 48. Cosine of 48. Okay, on the left, these things cancel. I'm left with h equals some decimal. Okay, and hopefully you found out that h is about 13.45 is my hypotenuse. So you should, wouldn't be a bad idea to try it with sine and see if you get the same thing. Try it with sine and see if you got, that was my phone getting a text message. Since that would ruin 3 minutes of video, we're just going to keep going. So you should try it with sine and see if you get the same thing. So you should try sine 48 equals 12 over h and see if you get the same answer. You should. Let's try another example. Okay, so I've got a right triangle here. Once again, very similar to the last example. I want to try and find my hypotenuse, which is SR, right? So I want to find that. I can use the same techniques as I did in the last example. We're going to go through this one a little bit quicker. I'm going to use sine. Doesn't matter what I use because I've got 32. I've got the leg adjacent and the leg opposite. I know both of those things. I'm looking for h. So I can use sine or cosine. I'm going to use sine because we used cosine last time to find h. So let's set this up. I've got sine of angle r is the one I'm given, so I'm going to use 32. Sine of 32 equals the leg opposite, right, because we're using sine, so equals 16 divided by h. Okay, so that's it for the geometry. Sine of 32, that angle that I'm given, equals the opposite leg over the hypotenuse, over h. Alright, so now let's solve for h. Multiply both sides by h. And I get down to h times the sine of 32 equals 16. Divide both sides by the sine of 32. Okay, and I'm left with just h. And you should get that h is about, should be approximately 30.2. The hypotenuse is about 30.2 units long. So this, once again, could do the cosine function. You should find the same thing. Okay, a little bit vocab here. So if you look up at an object, so you're looking up, the angle your line of sight makes with the horizontal line is called the angle of elevation. So this first blank here is the angle of elevation. If you look down at an object, the angle your line of sight makes with the horizontal line is called the angle of depression. Angle of depression. Okay, so if I look at my picture here where it says C, right, the angle of depression is this angle on top here. This is the angle of a depression. Because we can imagine you maybe standing at a hill or something up here looking down at some object, and so that angle that your horizontal line of sight makes with the line of sight that you look when you look down is the angle of depression. The angle of elevation is just the opposite. Okay, so this is the angle of elevation. If you were standing maybe down below looking up at an object, that angle is the angle of elevation. Okay, so that's the vocab, and using these we can figure out kind of more real-life examples, like the skiing example next. Okay, so in this skiing example, I'm given the angle of depression, right, because I'm standing up here on the hill, or the skier is standing up here on the hill looking down, so this is the angle of depression because he's looking down. That angle is 21 degrees, and I know that from the ground down here to the top of the hill where I'm about to kind of start skiing, that height is 1,200 feet. And my question is, if all these kind of bumps in the hill kind of even out, and I was just to go straight down, how far would I actually be skiing? And the thing is that I don't know this side of the triangle, right? So I can't use the Pythagorean theorem, but if I know an angle, and the side opposite the angle, 1,200, then I think I can find x, because that's my hypotenuse, right? If I got my right angle over here, my hypotenuse must be x, or this side opposite, where I'm going down the hill. So let's actually find out how far I go. I'm going to use the sine of 21 equals the opposite, 1,200, divided by the hypotenuse, which is my x, and now I just have to solve this for x. Multiply both sides by x. I get x times the sine of 21 equals 1,200. And then I just have to go and divide by sine of 21. And you should get that that's about 3,349 feet, roughly, that you're actually skiing is x. So that is an example of how we could use sine in kind of a real-life situation. Okay, the last thing I want to do is give you kind of an acronym to memorize sine, cosine, and tangent. It's called SOHCAHTOA. And to use this, we start with sine. So this is sine is S. And then we kind of use this to memorize it because it goes sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So let's write those in there. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so that's not a bad idea to kind of memorize that acronym, SOHCAHTOA, SOHCAHTOA, say it over and over, memorize how it's spelled, and then you can remember sine is opposite over hypotenuse, and it helps you remember cosine, tangent, all those things, so you can keep them all straight and remember, you know, is it opposite over hypotenuse or hypotenuse over the opposite, right? So I would definitely kind of log this into your memory. You've got it in your notes too. It's a good thing to have memorized, so you can remember all the trigonometric ratios. And that's it for this section. You should be ready to do the homework.